Cool. I Thanks for doing this, bud. I'm kind of just looking for like a rating of the content. I'm still working on like my execution of everything, so I may be doing a lot of ums and may not have my actual like way I want to articulate things down, but I'm just kind of looking for feedback on the content and if it seems lofty and dense. But yeah, thanks again for doing this, and I'm just gonna act like you are my audience now. Okay. Hey, what's up, guys? I'm Connor. I pretty much know all of you except for maybe a few people on the phone. But I'm here today to talk about Go. And I've spent the past couple months learning the language in my free time and researching it and reading about it. And I kind of just wanted to share with you what I've learned from that experience. So this will kind of serve as like a brief introduction to the language. We'll talk about why, if you're considering maybe learning a new language, Go brings some pretty cool things to the table, and may be well worth your time. But yeah. So just kind of a brief overview of what we're going to be talking about. We're going to get into a little brief history of the language, to give some context around why Go is the way it is. And that'll be a good segue into some features of the language, the most important of which is Go's support for concurrency and concurrent execution. So we're going to spend a good amount of time of the talk talking about that. We'll cover Go routines and Go's other concurrency primitives. And we're going to go over some sample code kind of while we're going through that so you guys can see them, and how they work and behave. And then finally, I'm going to show off a little sample project that I've been working on to demonstrate how a concurrent program can be designed, and how I at least attempted to utilize the concurrency to get the most out of the language. Just a note about that, I've only really been working with the language for maybe like 4 or 5 months, so I'm by no means a expert Go developer, but this project was just kind of my little stab at using the concurrency primitives to make a fun little project. So yeah, with that, let's talk about the history and the kind of why behind Go, and why it was created. So work started on Go at Google in 2004 and was designed and implemented by Ken Thompson, Rob Pike, and Robert Grissomer, which are some pretty huge names in the computer science world. These guys' resumes collectively include the C programming language, the Unix operating system, JVM, and all these hugely important projects in the world of computer science and software engineering. And these guys kind of had a problem with the current offering of a lot of modern programming languages. They wanted a language that was performant like C++, but didn't have all the nasty memory management stuff that comes with that, but also wanted a simple and readable and expressive language like JavaScript, but didn't want the performance hit that comes from an interpreted language. They also kind of felt like a lot of support for multi-threading and multi-core processing in modern languages weren't really well addressed in a lot of modern languages, and didn't handle things like thread locking and race conditions very well. But ultimately, that is to say, they wanted a programming language that kind of had multi-threading at the front of mind. And so yeah, so they started working on the language in 2007. And ended up releasing a public beta in 2009, and the first stable release was in 2012. And when the project was also open source then. And we're currently on version 1.13. And so in the past 7 years, since its public release, the language has remained largely unchanged in both syntax and features. And that's kind of a good segue into this next part where we're kind of going to look over the language features. But just kind of a little bit of a note about, how Go really values simplicity and doesn't really need change, which is something that I kind of personally really appreciate. So just kind of taking a look over some key attributes of the language. We're going to go through each one of these and talk about each one a little bit, and then do a deep dive into Go support and implementation of concurrency. So the first one we're going to look at is maybe ironically Go's kind of lack of features. Let's take a look. So here's a list of all the things that Go doesn't have. And so, especially if you're coming from an object-oriented world like me, you might be tempted to completely shut down for the remainder of this talk and just kind of write off the language as a useless piece of garbage. But I think the authors of the language actually had some pretty insightful reasons for leaving stuff like this out. And at the core of that is this kind of idea that more features doesn't really make a language better. Right? So every couple of years, there's this new version of Java or new version of C# that adds lots of new features to the language to help us implement solutions. And a lot of times we're tempted to think of these new features as making the language better. We're given more syntactic flair, given some new features. It must make the language better. And the authors of Go saw this and saw what high feature languages were doing to teams that they were a part of. And maybe this resonates with some of you guys, because I definitely know that it resonated with me. And they said, sure, features gives you more ways to do things, but it also gives you more ways to get in trouble. I mean, think about all the times that you have opened some legacy code that you didn't write, or you've opened some code that you wrote like 3 years ago, and think about how much time you spend trying to understand what that code is doing, or maybe how much time you spend kind of detangling this over-engineered spaghetti code to try and understand what it's really working towards. And so the authors of Go saw this and kind of came to this conclusion that features hurt readability. And not only do they hurt readability, they increase complexity, they encourage over-engineering, and overall they reduce expressive code. And so from that, they came to the conclusion that in their programming language, there should only be a few ways to do things. So in Go, there is, in fact, only a few ways to do things, which I personally really like, because none of the simplicity of the language stops you from implementing good code. The simplicity more so helps you to write readable code with low complexity, and ultimately just make better maintainable code that is more collaboration friendly. And so Go is fixed. So as I said earlier, since the public release, there's been no major feature adds or syntax changes to the language. So once you've learned the language and once you get the syntax down, in theory, it should be pretty easy for you to dive into any Go project and understand exactly what is going on. And that's something really nice. So this may seem kind of like a silly example, but this is just kind of to illustrate the simplicity of the language. On the left is some C# code, and basically this code just loops through a list of strings and prints it out to a console line. And I wrote out every way off the top of my head I could think of in C# of how to do that. And so you see we have like a for loop before each loop. We have a link statement that iterates through the list. There's some do while loops. There's just a while loop. And that is every way to do that. And then on the right, we see that there are only 2 real ways for you to do this in Golang. And that may seem kind of silly and pointless, but this is kind of to express that Go values less ways to do things. And Go also, and through that, it enforces this kind of simplicity and uniformity in your code that, in theory, makes it easier to maintain and easier for other developers that are looking at what you're doing to understand what your code is trying to do. And so, yeah, moving on from that, Go is a simple language that is at the same time performant. So if you guys have ever done any programming in C++, you know about all the grossness that comes from memory allocation and memory management and dangling pointers and all that gross stuff. And there's lots of developers that kind of just believe that this is the price you pay for having a performant language. But because of Go, that's no longer necessarily true. At least on the memory side of things, the performance that you get with Go is comparable to that of C++, while also having a latency-free garbage collector. In fact, all the memory management in Go is abstracted away from you. So there are some garbage collector configuration options you have with it, but unless you have like a super specific use case, there isn't a real reason for you to mess with those. So yeah, the niceties of a performant language with a latency-free garbage collector. And Go is also very performant because it compiles directly to a binary and runs on your machine's hardware versus languages that compile to bytecode or interpreted languages. And this also gives you a nice fast build time. So the build time for most Go programs are well under a second. And that adds and helps with ease of deployment, right? So all of your dependencies end up being included in that binary or exe, depending on what platform you're running on, and gives you a nice, easy deployment. And lastly, Go is designed with multi-threading and concurrent execution as a core philosophy of the language. For other languages like Java and C#, spinning up threads is relatively inefficient compared to Go's solution for concurrent execution. The main reason for that is that Go doesn't use threads, but instead uses something called Go routines, which we're about to talk about once we get into Go's support for concurrency. But just in terms of performance, I believe in Java, spinning up a thread costs about 1 megabyte versus in Go, a Go routine costs less than 2 kilobytes. So a pretty substantial difference there, and think that's pretty cool. So yeah, this is the big one, concurrency. Probably one of the most talked about and defining aspects of Go is its support for concurrent execution. And again, that's not to say that other programming languages don't support concurrent execution. Go just has a simple and efficient way of allowing you to design your apps in a concurrent fashion to get the most out of the machine that your program is running on. And so we're going to talk about what concurrency is, how it's different than parallelism, and then go into Go's concurrency primitives, which is its tools that allows you to design concurrent software. So just by a show of hands before this next slide, who all knows what I'm talking about when I'm saying concurrency or concurrent execution? You could probably infer, but yeah, right. So just so we're all on the same page, I don't love putting a Wikipedia definition on this slide, but this is the Wikipedia page for concurrent computing. And I think that it pretty nicely explains what we're talking about when we're saying concurrent computing. So it says concurrent computing is a form of computing in which several computations are executed during overlapping time periods concurrently instead of sequentially. And so one helpful way to think of this might be in terms of kind of breaking down what we're doing right now in terms of concurrently executing tasks. So let's try and do that. So here I am. This is me up here talking. And if you think of me up here talking as a task, you guys are listening to me, and maybe some of you are kind of messing around on your phone or texting each other about how much this talk sucks and how stupid I am, and how much you hate this. And so that is another task happening concurrently to that. And concurrently to that, there are our friends across the hall in the other practices actually getting work done. Right? So they're over there doing work. That's another concurrent task happening. And then maybe another concurrent task that's happening is people outside driving their cars to lunch. And so this is kind of a way to think about concurrent programming in the sense that this is how Go expects you to organize your apps. They expect you to think about it in terms of concurrently operating tasks. And at the core of understanding concurrency in terms of how it pertains to designing software is maybe understanding how it's different than parallelism. So up here is a link to a talk by Rob Pike, who is one of the authors of Go. And if you're interested in concurrent programming or any of the things that we're talking about today, I highly recommend you go check it out because it's a really, really great talk and really drives home this point. This guy actually does a lot of really good talks that are out there on YouTube. So I'll try and send out a list of all those after this talk. But there's a quote from this talk that kind of really nicely encompasses the difference between concurrent execution and parallelism. So concurrency is the composition of independently executing processes. And parallelism is the simultaneous execution of processes, right? And so if we go back to our example here and kind of look at all these tasks executing or potentially at once, or potentially not, and we think about me up here talking and you sitting in the chair doing something on your phone, while I'm talking, if you're on your phone, those tasks are executing in parallel. But then let's say you set your phone down and you're no longer messing around on your phone and I'm just still up here talking, then the execution of those tasks are no longer parallel, but the composition such that they can execute in parallel makes the design of this model concurrent. And so we're going to take a look at some code examples that may kind of help you understand better what I'm talking about with this. But effectively, why this is important is that Go wants you to structure your solutions in terms of these kind of concurrently executing tasks. Oh, okay. Yeah, so with that in mind, let's take a look at the tools that Go gives you to do that. So here's a list of Go's concurrency primitives, right? We have Go routines, channels, select statements, and the sync package. And I'll be going through each one of them, and with each one of them, we'll kind of be looking at some code examples to show you how they work and their behavior. Right, so let's get into it. So the first one, actually, I think I had this one in the slide. So the first one is Go routines, right? And so Go routines, as objects are the fundamental building blocks of C# and Java, Go routines are the fundamental building blocks of Go programs. And put very simply, a Go routine is a function that is running concurrently alongside other code. And so in Go, creating one of these is extremely easy. You literally just put the Go keyword in front of any function call. So let's take a look at a Hello World program, right? So this is a Hello World program in Go. Right, we have a main package, which you can think of like a namespace in C# or a package in Java, just a unit of organization for your program. We're importing FMT, which is basically just a package that helps you interface with the console in Go. And literally we just have a main function. Every Go program has a main function that prints out a hello world statement. So that is a simple hello world app. And let's say we wanted to run this in a Go routine. We could very simply declare an anonymous function and put the word Go in front of it. And now, whenever we call our anonymous function, this will operate within a Go routine. And we could even break it out into its own say hello function and just say Go say hello in the main function, and that will execute within its own Go routine as well. And so Go routines are completely unique to Go. This code is not doing anything with threads. And I'm actually not going to get into what is happening under the hood, but basically all you need to understand is it's doing some magic with Go's runtime to run these blocks of logic concurrently. And so you can basically think of Go routines like threads if it's helpful for you, but it's important to understand the distinction because they're much less expensive and much more efficient. And so let's move on to channels, right? So channels are basically just a way for Go routines to talk to one another. And effectively, you can pass anything you want to on a channel. Like you can pass structs, you can pass strings, interfaces, anything that a Go routine needs to pass to another Go routine to kind of implement your solution. That is what you use channels for. And the reason we need channels in Go is because in Go's philosophy of concurrent execution, you're never supposed to share state. So in order for you to design programs in terms of concurrently executing tasks, it is crucial that state is only ever communicated and not shared. And the philosophy on state allows us to avoid using things like mutex locks or semaphore locks, and gives us kind of some nice simplicity just with having these independent atomic functions executing side by side and communicating whatever they need to communicate. So here's an example of how we use a channel, right? And I'm going to go through this line by line and kind of explain what's going on, right? So again, we have two functions. We have our main function when we have a function called count. And in the main function, we are creating a channel. We create a channel using the make keyword. And we give it, we want to make a chan, which is a channel, that passes strings, right? So only strings can be passed on my channel. And then we are starting up a Go routine. And we are running our count function on a Go routine. And so we want to count sheep in this instance, right? So we're passing the string sheep to the count function, and we're also passing it my channel so that it can communicate back to the main function. Maybe something important to note here, the main function itself is a Go routine. So then what we're doing below that is we are iterating through all the messages that come through that channel and printing it out to the console. So what we can look at when we come down to this count function is we can see we're just counting from 0 to 5, and with every time we loop through this loop, we are sending the thing we want to count, which in this case is sheep. We're sending it through on the channel, it's getting printed on the console line, and then we're sleeping. And then after the loop is over, we will close the channel. So this is a common pattern in Go. It is the responsibility of the function sending on the channel to close it up, because if you don't close it, it will deadlock and you will basically not have fun. So so here we have two concurrently executing functions and channel to communicate between them. So if we wanted to too, we could have another channel in here that passes from main to count. But in this case, we're just going one way from count to main. And this is a very simple example of how we would implement a channel. Right, so the last real important concurrency primitive we're going to talk about is the select statement. And this is the mechanism that kind of helps synchronize this entire process of concurrently executing tasks, sending messages across channels to one another. And you can kind of think of this like a switch case statement for channels. However, it's important to distinguish that they don't execute sequentially, meaning like they don't go, the case statements don't go one by one. They only execute whenever a message is fired onto the channel that we want to use. So here we see we have the select statement, and we have three channels. We have channel 1, channel 2, and channel 3. Every time a message is fired on channel 1, we are setting it equal to some variable called some work message. And this operator right here, the colon equals, is just a type inferred operator. So in this case, it's a string and it knows that it's a string. So then we'll print that out to the console. Same thing with this. Whenever a message is fired on channel 2, we get it here, printed out of the console, and channel 3, same thing, printed out of the console. So let's take a quick look at where this code actually comes from. I have this channels.go right here. Let me uncomment that. Actually, I want this select.go. That's what I want to look at. Great. So here's how we're using this, right? So we have 3 channels that we're creating, and we have 3 Go routines that we are running. So we have our functions do some work, do some other work, and then do some different work. And we're passing, I'm doing work, I'm doing other work, I'm doing some different work to those functions. And then we have, typically you would have some sort of condition for your select statement to listen on. But in this case, these functions are just infinite loops that are just passing strings on the channels. So we have an infinite loop for our select statement. And basically what you'll see is that each one of these concurrently executing functions is passing a message and sleeping for different amounts of time. So let's take a look at what that looks like whenever we want to run it. So let's close that out. Okay, clean that up. And we'll say go run select.go. And this will just run our select file that we have in our project. And as you can see, the functions are all running concurrently and they are passing through their messages to the select. And so again, the select statement is to act as kind of a memory synchronization or messaging synchronization switch through which all of the channels in your program can run. And so yeah, let's kill that. Let's head back to the slides. So before we get into the demo project, I just wanted to talk really quickly about the sync package. So the sync package is, in Go, is a package that has all of your traditional memory access synchronization stuff. So things like mutex are in here. And so if you wanted to write a traditional program that has shared state, the features of Go actually allow you to do that. Even though you're not taking advantage of the main concurrency features of the language, it's kind of like a no-no to use the sync package, but you can do it if you wanted to. But the main reason that I bring it up is that it does have one useful tool that we can use, which is the wait group, which can be useful in certain instances. So let's go back and take a look at our Hello World app that we showed at the beginning. I think it's in this file. Yeah, great. And I've already got the code in there, which I will not have normally. So in here, let me grab, lost it. Okay. Let's write our Hello World app again. So we're going to say go func and then fmt dot println hello world. Oh, and then that. Okay, great. Right. So we have our hello world executing on a Go routine right now. And so let's pop open the console and let's run this and see what we get. So unexpectedly, the program just exits. And maybe some of you did expect that, maybe some of you didn't, but effectively, what is happening is that because we're creating a Go routine, the program continues execution. Go routines are not blocking calls. And the reason that on our other programs where we have our other things that we've looked at, like that we're using channels, is because the reason that other programs that we have written and shown off tonight is because in the select statement, one, block this, block this, block this, ignore this part. The reason this is happening is because when you create a Go function or a Go routine, it tells the program to continue execution. And it doesn't block on the current executing function. And so most of the time, this isn't a problem because we're using channels to communicate between Go routines. And when using channels to communicate between Go routines, sending and receiving on channels are blocking calls. Therefore, you don't have to worry about kind of waiting for the Go routines to execute before you get done because you're blocking on sending on the channel. So in an event that you wanted to actually have a Go routine run that didn't send anything on a channel and we wanted this to work correctly, we can use what's called a wait group. So the way we do that is let's create a variable and we're going to just call it WG, and we're going to import the sync package and give it the type wait group, right? So now we have our variable that is a wait group. And the way to use this is that we have to add to the wait group we have to add 1 to the wait group. So what this is saying I am waiting for, effectively, I am waiting for one go routine to be complete. And so then what we want to do is we want to come into our go routine here, and we want to say wait group dot done. Or sorry, we want to say defer wait group dot done. And the defer keyword basically just says wait to execute this last. This is kind of just like a nicety of saying I need to call wait group done whenever the function is complete. So rather than putting it at the very end or having to remember, like let's say you have a really, really long function and you forget to put it at the very end, this is just a nice way to put it at the beginning and it will execute at the very end. And so that lets the wait group know that the go routine is completed. And the last thing that we have to do is call wait group dot wait. And basically, so what happens now is the go routine will execute, or the go routine will be spun off, and the execution will continue, and then the wait group dot wait will wait for wait group dot done to be called. So if we come back to our terminal here and take a look at it, we see hello world printed out to the console as we expect. All right, so let's move on to the demo project. All right, that's all I have so far. The demo project isn't ready, but it's not important. Thank you for listening to me. I hope this wasn't too annoying or too dry or too bad. It feels lofty right now, so I kind of want to know if you feel that way too, or if it's like you think it's bad or whatever, but just, I don't know. Give me some feedback. I appreciate it a lot, dude. Thanks.